Dear student, today we will learn the length equation. Length equation is the relationship, the relation between the object distance do, image distance di, and focal length f. It's called the length equation. So first of all, let's discuss the di, do, and f. Then we will derive the equation. For instance, this is a double convex lens. This is the principal axis line, and here at the middle this is the optical center. At one side there is a focus, on the other side there is also focus. Why this is called focus? Because if a parallel rays are falling on the lens, after passing through this lens, they will meet at one point. They will be focused at one point. So the point where all the rays meet, that point is called focus. And the distance from this focus to this optical center is called focal length. So in the relationship, the small f stands for the focal length. Now, in order to derive this relation, let's draw a simple diagram. For instance, I take a convex lens. This is a convex lens, and then optical center, the horizontal straight line passing from the optical center is called principal axis. At both sides at equal distance, I consider this as a focus, and at the same distance I took another focus which is called 2f. Now for example, the object is placed in front of the convex lens. If this is the object and the height of the object is known as HO. Now the two rays that we should draw to form the image, if one ray is going parallel to the principal axis according to the rule, it will pass from the focus. This is mentioned in the previous topic. Similarly, if there is another ray which is passing from this optical center according to the rule, this ray will also go straight. So in this way the image is formed here because the rays are meeting here. So the point where all the rays meet, there will be the image, and the image height is represented by hi. Now the distance of the object from the lens, like this is the optical center, the lens, and till here is the object. So this distance is known as distance O, do, because this is object distance. Similarly, from this lens to this focus, this distance is known as focal length, and the image which is formed here and from the optical center, this distance is known as di. So the relationship between this di, do, and f is called the length equation. Let's derive this length equation from this diagram. In this diagram, first of all, we consider the two triangles shown here. For example, one triangle is this one, which I just making the dots inside the triangle. One is this triangle and the other triangle is this one. So these are the two triangles. If you look at the symmetry, these two triangles are equal triangle, isosceles triangle you can say, because these angles are equal, they are alternate, and this angle is 90, this is also 90, so that's why we can call it isosceles triangle. Now in these two triangles, if we consider the tan theta from here, like suppose this is theta 1 and here this one is theta 2. So if I consider theta 1 is tan theta, tangent theta mean it is the ratio between the perpendicular and the base. So here from this triangle, HO is the perpendicular, so perpendicular divided by base, they are the base. So the base is given as DO. So tan theta is equal to HO divided by DO. Similarly, in the other triangle, let's take tan theta 2. If this is theta 2, then the opposite side, this one is perpendicular, which is HI, and this one is the base, which is shown by DI. So I can write that the perpendicular is HI divided by DI. Now, as you know that the two angles are equal, so we can compare these two values. Let's say this is equation number 1, this is equation number 2. By comparing, we can write that HO divided by DO is equal to HI divided by DI. If we just a little bit rearrange it, so the HI will come at the denominator here, so we can write HO divided by HI, and this DO will be shifted to the place of HI. So we can write DO divided by DI. Let's say this is our equation number 3. Now in the same diagram we have two other triangles which are equal, and the triangles are, let's say this one, the red dotted circle, and similarly one triangle is this one. Now these two triangles are also equal because there is alternate angle between them. We should take the same thing over here as well. Now in this triangle, if I consider this theta as theta 3 and this one angle is theta 4, so again we should consider theta 3 as tan theta 3. Now look at here, if I take tan theta 3 is equal to perpendicular divided by base. This is the perpendicular which is almost equal to this HO. As by symmetry they are equal. So HO and divided by this distance which is given as focal length. So I can write tan theta 3 is equal to HO divided by focal length. This is again equation number, for example, 4. Now in the other triangle, if I take this tan theta 4, so the perpendicular is this HI and the base is this distance. Now if we just calculate this distance first, so let's say I want to remove these two angles. We know that the total distance here, the total distance from the lens to this one is given as DI, and we know that this distance is given as F. So this, the remaining one, this one, so we can write this as DI minus F. So this distance, the base one, we can calculate as DI minus F. Now if I take tan theta 4, I will write tan theta 4 equal to HI, yani perpendicular, divided by base, which is DI minus F. You can see it again. This is DI minus F. So DI minus F, and this is equation number 5. Again, by comparing equation number 4 and 5, we get that HO divided by F is equal to HI divided by DI minus F. Now by cross multiplication, we can write HO divided by HI is equal to, shift the F to the HI place, so F divided by DI minus F. This is equation number 6. Now if you look at the equation number 6 and the equation number 3, they both have the same left hand side. So by comparing this equation number 3 and 4, we can move to the final result. So by comparing equation 3 and 6, so DO divided by DI should equal to F divided by DI minus F. Now just do the cross multiplication, like we should multiply these two